as a very good technical community. So we thought let's also talk about how DPDK technical governance takes place, and we want you guys to contribute. So we want to give you an overview how DPDK governs the project technically. We are not talking about managerial aspects here. So when the DPDK project got started, it was a single vendor, and things were very easy to maintain, like you can do a consensus and everybody can just come together from a single company and people were contributing to DPDK. But later DPDK started growing. More vendors, different architecture, they wanted to put their code into DPDK. And there are quite a few instances where we were not able to reach consensus, how to do the thing rightly. So a DPDK technical board was formed across vendors, across architecture, nominating the people who are the most trusted contributors, and then the DPDK technical board was formalized and it was put into the DPDK charter. So what is the DPDK technical board? Now DPDK technical board has 9 members from different companies, largely from Intel, Mellanox, KVM, NXP, Microsoft, 6Wind. One of the DPDK technical board member on a rotation basis, he goes as a representative to DPDK governance as well. Right now, Jarin is the nominated member for the governance board for this quarter. Typically, on a DPDK technical board, we have a IRC-based open meeting every 2 weeks. There is a fixed time. We announce the DPDK meeting every 2 weeks to the DPDK mailing list as well. Anybody can come and join on IRC. Typically, it includes approving new functionalities, approving new subtrees, creating, giving opinion on the new projects, or providing technical input if somebody is looking for a technical input for a particular contribution. And we can also talk about there on a voting basis that technical decision if we are not able to reach any consensus for a particular topic on the mailing list. Because we don't want the fighting to happen on the mailing list. We generally take those topics off list and we can talk about them in the technical board meeting, and it's a public meeting so anybody come and can see. One of the major things we did with the DPDK, because as the DPDK is growing, more and more people are companies, customers have started using DPDK. So we want to make sure about that we are not violating any intellectual property and we are aligned with the intellectual properties. So we put a proper format how the DPDK code should be licensed. So right now, DPDK as a user space, the code is licensed as a BSD3. There are some exceptions, like the kernel code is GPL v2 licensed, and the files which are common between kernel and user space, they are naturally dual licensed, GPL v2 and BSD. And in order to ease out, like because we have to also see the size of the code, and we see every file having a big license header for BSD, we decided let's move out. So we introduced the SPDX concept, which is also a Linux Foundation project, and we started putting these small tags, SPDX license identifier and a small copyright to each file, and we have from 1802 onwards, we have started removing all the copyright information, the big license tags from the source file, and we have moved to the SPDX license tags, and we are targeting in next 1 or 2 release, we will make whole DPDK SPDX compliant. Having said that, when you are putting your code to a BSD3 license, many times there are contributions which come from a different license. For example, if somebody is contributing a code from Apache license, or somebody is contributing a code from BSD4 or BSD2 license, how to deal with these things? So first thing is, on all such cases, the technical board comes into the play. Technical board sees if there is a merit to that contribution, if that contribution is important for the community, then we go and talk to the governance board, whether we should add, if the governance board is okay to accept that as a legal proper license for the DPDK or not. There is one help which we are looking for right now. All this license check in the each patch is right now manual, and we are looking for a automation. So right now in our patch work, some people are working, but if any volunteer, more than welcome to join us and help us in automating the patch check with respect to the license. DPDK has many repositories. The main repository is the dpdk.git, but there is another stable tree. I will talk about the stable releases later, but there are repository which maintains the stable trees. Then there are tools like DPDK website is maintained by DPDK web. Then there are applications like PacketGen or Soft Switch panel. They are also maintained. And as a standard open source tree, we have our staging trees like NetNext, NetCrypto, and different kind of tree. And we also have a concept of draft tree, because whenever some big proposal comes and we don't want it to disturb the main tree, we generally give them a draft tree so that community can work on the draft tree, and once the proposal is finalized, we can move them to a next tree or to a proper DPDK tree. DPDK generally makes 4 releases every year. That means a release every quarter. Like we do a release in February, May, August, and November. Out of these 4, only 1 release is LTS. So right now 16.11 is a long-term stable release, 17.11 is also an LTS release. Because it takes some effort to maintain a LTS release, so that's why we are only doing 1 release a year as a LTS release. Typically, there are maintainers. Generally, the role of maintainer is to answer question and make sure that patches related to that particular modules are reviewed. There are main committers. The committer's responsibility is, the main responsibility is to make sure that patches are reviewed on time. And we are looking for reviewer, because right now at each open source community, we also have a problem that patches are not getting reviewed on time for many of the things. So please come and review our code. DPDK has quite a few tools with respect to the maintenance. Like we use the Patchwork for reviewing and maintaining the patches. There is a CI integration which automatically checks for the compilation as well as the coverty and other issues. Then we are right now setting up a performance lab. I will talk about that in a different slide. We have recently set up a Bugzilla for reporting bugs on the DPDK, and DPDK roadmaps are right now being published on the DPDK website. So we felt a need for a DPDK Open Lab, and the main reason was that whenever somebody is contributing a patch, we have to make sure that that patch is not doing a regression on anybody's platform, because there are now multiple platforms. Intel is supporting, many of the ARM vendors are supporting DPDK, PowerPC vendors are supporting, and then there are Linux architecture, there is a BSD architecture, and Windows architecture is also coming up. So we have to make sure that your patch is not breaking and not doing any regression on any of these architecture. So we have set up a lab, and right now the lab is being set up in the University of North Hampshire. We have already signed the contract. Right now, Atomic Rules, Intel, Mellanox, and NXP are shipping their boards there. Intel and Mellanox has already shipped the board. Other 2 are in the process of shipping the board.
Thanks. Hello. Yeah, thanks, Hemant. So this is not the final list, but we picked up from the mailing list what are the few items that can come up on the next release. And since it's an open source community, so anyone can contribute. So this list is not final, but trying to touch upon the items what we saw on the mailing list. Yeah. Yeah, so this one is the existing release. I'm going to talk about the roadmap next. So this one we covered about, we introduced the SPDX license header, as Hemant mentioned. And DPDK is now currently abstracting all the hardwares. Right? So like we have started with Ethernet device abstraction, then they had a crypto device, followed by we had a scheduler device hardware abstraction, it's called EventDev. Then we recently introduced something called wireless baseband device. This is abstracting hardware devices that have with wireless baseband capabilities. So this way, currently we have a software driver with that. So and future will be enabling, or anyone can add the hardware support to that thing. So in that way, so applications will not get changed. The same API will be used for both software and hardware in transparent way. And we introduced the raw device class, where there are some type of devices where it does not exhibit a common attributes. So like some of the LTE devices or timer devices or anything that category. So NXP introduced a subsystem called raw device where it's just set of functions pointers for enqueuing, dequeuing any type of void pointers. So we can plug in any kind of devices to that thing, and we can have a unified API to get access to the application. So then after that, we introduced ETH probe notifications and ownership and Hyper-V platform driver. So this is a recent improvement where earlier the DPDK was very much biased with the PCA device itself. Then we introduced a bus driver where any type of buses can be added to the DPDK. So the first one was PCA. We moved to that. Then the SOC specific buses were moved into that thing now. As another bus, we added a Hyper-V also. Then another feature was AVF Ethernet driver supports. This was a good feature where the problem statement was something like, in a virtualized domain, so we may really don't know what kind of Ethernet hardware may be running underneath, right? So what we did is like typically if you see in different hardwares, like we'll have a base, the hardware structure for the ring descriptor for the hardware devices typically will be same. So what we did is we created a minimal driver which has a bare minimum functionality like transmitting and receiving the packet, but the same driver can run on any, meaning say, different type of devices from the same vendor. So that way you don't need to worry about in a virtualized domain, like what is the real underneath device is sitting there. Then we added an IPsec inline offload support for DPA. So basically we created a framework called RT security, which is going to talk by Hemant next slide. So which is nothing but, if you see latest hardware capabilities, we have, there are hardwares where we can do the complete IPsec inline offload support in hardware. So this framework creates that abstraction, and we plugged in one offload as a proof of concept. Then, yeah, so then event dive driver, and so we'll move to the roadmap now. Yeah, so these are not the final list, but whatever items we got it from the mailing list, we added here. So the one thing is like we are going to have a Windows support. So Linux, the DPDK has EAL abstraction where you can plug in different execution environments. So it can have a bare metal system or Linux or Windows. Currently, Linux is the free-based. Linux and free-based is the only execution environment is supported. So this is going to add the Windows support. And Hyper-V support, full-fledged support will be added through bus subsystem. And there is compression API support. So the latest hardwares, we can have a compression hardware where you don't need to take the CPU cycles to do the compression. So we are creating a new compression API framework, which is going to talk by other people. So it's going to add that, and we are going to have a standard software driver and hardware driver for that thing, so that applications can use the same API. Then the new security offload like MACsec and other things. So IPsec is added now, so new support like MACsec or asynchronous support and things like that. And STP support is a new thing is coming up from the Linux world, where there is a means where we can do the zero copy to user space through XTP driver. So this is a standard PMD driver which will run on top of XTP to get the packets to user space, so that we can leverage the Linux subsystem for getting the packets to user space without memcopy. And yeah, we have a new build system which is it's very fast now. So currently the make system is not really good because it has a lot of dependencies and things like that. So which is fixed to with Ninja build system. So and it follows standard package config model where you don't need to have a specific configuration things and like that. So as a user space library, this is going to be enhanced with new build system. And memory management support, to add the hot plugging. And yeah, the Virtio crypto driver is going to add. So Virtio net driver is currently there, so that in guest, you can get the packet without any hardware acceleration scheme. So the similar stuff is going to happen on the crypto side, where they will standardize the descriptors for a crypto work, so that in guest, with the hardware accelerated backend on the host, we can get the crypto work. And yeah, so we had an event dev subsystem now which can inject the Ethernet packets now. So this is going to be extended to add crypto support, where once you submit a work to crypto, and once crypto work is getting completed, it can notify back to event dev. So that adapter plugging logic will be added to DPDK. Again, so with that scheme, both software and hardware scheme will work transparently, so application does not need to change. So crypto adapter is going to add. In addition to that, there is a timer adapter for event dev, where the timer expiries, instead of callback, it will be get added to an event dev as an event. So an application can get an event and see that the timer got expired. So, and we are going to add more event dev examples. So currently we have multiple examples like pipeline and other things. So we going to extend the L3 forward and another standard applications to put in more event dev framework for scheduling support. And raw devices support is already available, so we're going to add a new devices and command line library more. So that's it. So any questions? Yeah.
So there are mics on both sides.
Oh, okay, I got it. So when you say Windows support, is it like Open vSwitch support? Are we going to have a DPDK based Hyper-V virtual switch also in
Yes.
Windows Server?
Yeah, so Windows support, what we meant is like we have an execution environment that runs on Linux and FreeBSD now, right? So now DPDK can run on standard Windows, where all the standard applications can run on Windows itself.
Okay. So my question was OVS DPDK has come in, right? So which actually adapts Open Virtual Switch in DPDK framework.
Right.
So my question was more inclined towards whether the Windows Hyper-V virtual switch, will that also come with DPDK support, or we can compile it with DPDK in Windows machine itself?
So right now, the first step towards it is there are contribution from Microsoft and Intel, and there is already a draft tree created in the DPDK community, where as a first step, the DPDK itself is getting plugged into with the Windows support into the DPDK community. And right now we are not aware of the patches with respect to the OVS, but DPDK community as a standard open source community, it's open for any contributions and any suggestions.
And once Windows environment support is added, then they can use the same DPDK APIs, right, on the OVS Windows platform itself, right?
It's
so
an open source community, so anybody can come and contribute, right? We have not seen the contribution towards OVS yet.
Okay. One more question regarding.
Yeah. Kanan, you want to?
So as Hemant said, we are adding the basic DPDK enablement in Windows. Yes, of course, the follow-on will be the visual switch. Hyper-V switching also will be targeted for the DPDK enablement as well.
One more question. When we say Hyper-V support, is it like now in Hyper-V the VM bus architecture will be integrated, or will it be still a virtual device architecture which is current?
Yeah, it's marked as a bus, so it's just a generic bus stuff support we added as a bus framework. And so I think in this support, I think Mellanox is going to work on that. Microsoft and Mellanox combined, they're going to working on. I don't know what exact features are going to add it. So the base bus support will be added now.
Thank you.
We'll take one more question.
I have a question on the NIC support basically. So I was recently working on DPDK plus OVS, right? So I had realized that the Realtek NIC is not supported as of now, right? So I just wanted to know if we have any plan to make it NIC independent.
See, DPDK, if you see DPDK is actually a set of drivers. It's just a small abstraction layer over the hardware drivers. So that NIC, I don't know who it belongs to, but that NIC, they need to provide a driver to the DPDK, and they can seamlessly plug the driver to the DPDK, because DPDK is all about talking to the hardware in a most efficient manner. So DPDK provide a small common API over the hardware drivers. So we need to have that hardware driver submitted to the DPDK, and then only it can work. Because as an open source community, we don't write drivers for other hardware. The hardware vendor has to submit their driver to the DPDK.
So you want to say that the Realtek guys has to put the hardware drivers and that will be included in DPDK?
Yeah, if they submit, we will include it. There is no reason we will not include it.
Okay, thank you.
Another thing to add is like if you want to have a generic driver, you can use a Virti or any other platform neutral drivers.
AF XDP driver, AF packet driver you can use, but you will not get the best performance in that case.
One more question I have, sorry. So when we are talking about DPDK, we have one more option that is called as SRIOV, right? So SRIOV seems more appealing than DPDK, because the thing is that in the case of DPDK, we have to reserve the CPUs and the memory, but in the case of SRIOV, that is not required at all. So how you want to see that in future?
No, it's both same thing. It's a different technology, right? So you are talking with respect to the virtualization context, right? So the PMDs can run on top of the direct SRIV. So don't need any other CPUs to get the packet. So if with an SRIV, so DPDK and SRIV married together. So you can have a PMD which runs on top of direct SRIV.
Okay, thanks.
Okay, thank you.
Thank you.
You can get in touch with